Hi math students, it's Miss Carol here, and we are now working on Project 3, and we're working on the first lesson in Project 3, which is Lesson 11. So we've got 5 questions to cover here, but I don't think any of them will take too long. Let's start out with the situation. Law enforcement officers and detectives are responsible for more than investigating and solving crimes. They also keep track of crime data so that they can make predictions and decide how to fight crime in the future. Sometimes the information they gather is incomplete, and therefore an inequality comes in handy for interpretation and prediction. Use your knowledge of inequalities in one variable to write and solve inequalities that involve crime rates in the town of Blotterville. Okay, so our first question. In the month of June, there were 13 citations given to teenagers for fighting in Blotterville. When you subtract these citations from the total number of crimes for the month of June, there were at least 32. So at least 32. That's a big hint. So that tells me that at least 32 would be something like this. 32 is the smallest number, so it could be 32. That's where my or equal comes in. And the amount of citations is going to be greater than 32. Okay, so there were 13 citations given to teenagers, and if I subtract these from the total number, it'll still be greater than 32. So what I'm looking at here is X is my total number, and 13 is the number of citations given to teenagers. Okay, so I believe that this is the inequality that best represents this situation. The total number of citations minus 13 is greater than or equal to 32. And that would be this one right here. Okay, so let's scroll down, and the next question asks us to solve this inequality and to solve it for X, to find the number of crimes other than fighting for the month of June in Blotterville. Okay, so in order to solve this inequality, one of the things that I often do, I'm going to just scroll up here so it's kind of at the, well, it doesn't matter. Let's do this. Okay, and we're just going to rewrite that. X minus 13 is greater than or equal to 32. One of the things that I like to do with these is just to take this inequality out. I'm going to set it over here and say greater than or equal, and I'm going to rewrite this with an equal sign. X minus 13 is equal to 32. And we should all be pretty familiar with how to solve this. In order to get X all by itself, we need to add 13 to both sides. Okay, so when I add 13 to the left, I have a minus 13 and a plus 13. I'm left with X. And when I add 13 to the right, I get 45. So X equals 45. Now, the thing I can't forget is to substitute that inequality back in. So I have X is greater than or equal to 45. Okay, and that makes sense. I can plug that back into my original inequality. 45 minus 13 is greater than or equal to 32. And 45 minus 13, 32 is greater than or equal to 32. Okay, so 45 is the smallest number that X can be. X could be 46, 47, X could be 112. Okay, as long as it's bigger than 45, that is an accurate statement. So if I go type this in here, it'll look like this. X is greater than or equal to 45. Okay. All right, first 2 questions done. Next question. There were 25 vehicles stolen in Blotterville in the month of August. This includes both cars and motorcycles. The number of cars stolen in August was less than 13. Okay. So let X represent the number of motorcycles stolen in August. Okay, so let's see, the number of cars stolen is going to be 25 minus X, right? Because the number of motorcycles plus cars stolen, right, equals 25. All right. And the number of cars stolen is less than 13. All right. So motorcycles stolen equals X. All right. So I know that 25 minus X, all right, so 25 minus X is cars, okay? And I also know that cars is less than 13, all right? So 25 minus X is less than 13. Does that make sense? That makes sense. Let me just verify. There were 25 cars stolen in Blatterville. Number of cars stolen in August was less than 13. Yep, so 25 minus X is less than 13. Okay, so this is going to be an interesting solution here. I can't wait to solve it with you. But we can see that that answer is right down here. 25 minus X is less than 13. Okay. So let's go ahead and scroll down to the next problem where they want us to solve this. So 25 minus X is less than 13. And keep in mind, it's not a less than or equal. Okay, but I am going to go ahead and substitute my equal sign here just so I can do a solution. So I'm going to have 25 minus X equals 13. All right. One thing that I can do here is I can subtract 25 from both sides. So let's do that. Minus 25 and minus 25. So now this goes away and I have minus X equals a minus 12. All right. Now it's super tempting to just say, oh, well then X must equal 12. But right now, I have to take into consideration the fact that this negative actually represents a -1 times X. Okay, so I'm not going to touch this until I put that inequality back in here. So I'm going to say negative X is less than -12. All right. The reason I'm not going to touch that is that I know when I have a negative, in this case -1, that's being either multiplied or is dividing into the variable that I'm trying to isolate, I am going to need to switch the sign of my inequality when I get rid of that negative, okay? So when I do this, when I divide both sides by the -1, all right, I have to switch this sign. So while this goes away, my inequality changes to a greater than, and my -12 goes to a +12. All right. Now, if I just had this, if I had X is less than -12, okay, or even let's say I had 2X is less than -12, although this is negative, the number that's being multiplied by x is not negative. So my sign wouldn't change in this situation, okay? This situation, the number that's being multiplied by x is a negative, so in order to isolate this variable, I have to switch the sign of the inequality, okay? So, and we can plug the original numbers back in just to verify, but what this is telling me is that x has to be greater than 12, the number of motorcycles stolen has to be greater than 12 in order for the number of cars stolen to be less than 13, right? So 25 minus 12 is, and so I guess we have to say 25 minus 13 because we need a number greater than 12. We can't say 25 minus 12. So 25 minus 13 is less than 13. 12 is less than 13. That totally makes sense. Now, if we had left the inequality sign the same, if we had divided by that -1, but not changed the direction of the inequality, we would have had x is less than 12, okay? Well, a number less than 12, 25 minus 11 is supposed to be less than 13, but 25 minus 11 is 14, is less than 13. That is a false statement. So that's when you check the answers, if it doesn't come out as truth, you might go back to look and see if there was a negative sign that meant you should have changed the direction of the inequality. So in this case, our answer here will be x is greater than 12. Okay, so 13, 14, 15, any of those numbers will give us a situation in which the number of cars stolen is less than 13. Okay, just about done. Last year there were a total of 260 crimes in Blotterville. This year there were more than twice as many crimes. Officer Rodriguez says that the situation can be represented by the inequality x is less than 2 times 260, but our Officer O'Shea says that the situation can be represented by the inequality 1/2 x is greater than 260. So really, I think the indication here is that it says there were more than twice as many crimes. The way that Officer Rodriguez has written this is that there are less. He's written that there are less. This is a less than sign, less than 2 times 260. Officer O'Shea wrote that 1/2 times x is greater than 260. I can rearrange that equation. 1/2 x is greater than 260. I can multiply both sides by 2/1. So I would have x is greater than 2 times 260, which is, they're both of their numbers said the same thing, their equations said the same thing, but their inequalities were different. Okay, so Officer O'Shea had the inequality sign going in the correct direction. They both had the same mathematical expressions, but the inequality signs were what were different, and Officer O'Shea was the one who was correct there. So that's what you need to type, that the expressions, the mathematical expressions are the same, but Officer O'Shea had the inequality going in the correct direction. So that's all I have for you. Thank you so much, and come back for lesson 12.